Hey you guys, welcome back to the channel PHYSICSSIRJEE, and here we are again in JEE Advanced Solutions series, which I call it as alpha and omega of your preparation. It's the starting and ending of your JEE preparation. Okay, so we are going to go ahead and analyze the wrong JEE question on surface tension that has been requested by many students in the 2020 paper. It was in paper 2, I guess, and it was a question which is inspired from a previous Olympiad. And also it's a standard experiment where you start actually putting drops on a coin is assumed to be some cylindrical structure on which these drops are being poured, which is shown in this diagram. And over a period of time, the drops, due to the aspect of surface tension, are going to bulge like this in a side view, and at that point they will break. Okay, so why I boldly said this is a wrong JE question will be analyzed, and not only we will try to prove why it is wrong in multiple analysis, that is force and torque, but also we'll try to understand the question and the concepts behind it. Okay, any wrong question when dissected and post-mortemed in a proper manner gives us in-depth understanding for a future situation. Okay, so with that positive intent, let's try to see the problem statement provided by the IIT in the 2020 paper. Okay, in case you have not yet tried this one, I would request you to pause the video here and go through the wording and try it out for 5 to 10 minutes, and do come back for the complete concept analysis and multiple ways of looking at the solution. And also at the end, we'll round it off with the 2 practice problems to strengthen our understanding. Okay, and also one more important thing, I'll also talk about it at the end of the video. The next video in our channel will be uploaded if and only if we cross somewhere around 500 likes for this particular video. And it is very, very important for me to put this condition, because a lot of students just I feel appreciate the video. I could see that in the comments. I understand the unconditional love, but generally they forget that liking a video is free. Okay, and it provides with lot of motivation for me to carry it forward. Okay, so 500 likes, or maybe even you can call it as 8,000 subscribers, right? So in case you share, then people subscribe to the channel. So these 2 conditions, any one of them, 500 likes or 8K subscribers, would be my next target for the uploading of next video. Whatever target I have kept usually happens in my channel within 10 days. So in case you don't do it also, I'll be coming up with the video in 10 days. I have interesting set of 15 to 20 videos that are lined up for the next month, but I would be uploading them only when these conditions are fulfilled. In case you want to go it slow and you don't want to share the content, it's fine. I understand, because of the competition that might use this channel, because of the quality that is being provided, it's fine. Then you will be only getting a limited content from now onwards. I need to be a bit strict so that I understand that the motivation should be there to produce the videos, which are in fact free. Okay, so let's move forward with that condition. When water is filled carefully in a glass, one can fill it to a height h above the rim of the glass due to the surface tension of water. To calculate h just before water starts flowing, model the shape of water above the rim as a disk of thickness h having semicircular edges as shown schematically in the figure. When the pressure of water at the bottom of this disk exceeds what can be withstood due to the surface tension, the water breaks near the rim and the water starts flowing from there. If the density of water, its surface tension, and acceleration due to gravity are numerically given, estimate the value of height h at the time of breaking in mm was the question. This was a numerical based question. You can answer it up to 2 significant figures after the decimal place. Okay, so with the question out of our way, right, I would request you to check a video that was done much before the JEE Advanced 2020 happened, and it was a modified Pathfinder question. This question happened to be in Pathfinder, but I modified it to include multiple concepts in this, and this was done way before the JEE Advanced 2020. Okay, so the bonus concept and the link of this particular video are in the description below or the I button above. Please do check it out in case you are new to this channel, and we will carry forward the free body diagram and the analysis in this particular video, just to shorten the length of the video, because there are many more things to cover in this video. Okay, so in case you have already done that, I'll just try to borrow a quick recap of the FBD from that old Pathfinder video where this bulge was never considered to be semicircular. Okay, right. So this is the diagram of the bulge where I'm cutting it here carefully and drawing an FBD at this particular place. In that Pathfinder question, the angle was never mentioned to be 0 degrees here. That means contact angle was 180, not 180 degrees, because it was mentioned in terms of theta. That's why this kind of FBD occurred. Alpha in my diagram was mentioned as the surface tension, and this FBD had a DL width into the board, so that this is slight volume element, so that I can take weight and all that. Okay, so alpha times DL surface tension acted this way, and this red colored surface tension also acted in this direction. On this side and this side, the pressure forces, only the gauge pressure force, the P naught effectively gets cancelled. Only the gauge pressure force, which was calculated as an average and explained elaborately, was taken in this manner. Okay, so when you balance the horizontal forces, listen to me very carefully, all the horizontal forces, these were all leftward forces. Okay, and the rightward forces were this. So when you balance these two and cancel out the DL that I had taken everywhere and rearrange, you end up getting this expression. Okay, and please remember, a lot of students commented in that old video also, sir, who is balancing the vertical forces? We didn't need to, but there is someone balancing the vertical forces also. Okay, some students questioned in the comment section that this alpha DL's vertical component and MG's vertical component are only visible in this FBD, and there is no vertically upward component. Okay, so we'll analyze that as we move forward in the present video. Okay, and also we'll do extra thing which is called torque balance to prove where JE went wrong. Okay, right. So imagine this thickness T is the height h in the JE problem, and this expression is correct. And if we apply that in the JE question, let's see what students got it in a correct manner. So borrowing the result, this T is your h, and theta is 180 degrees here, you could see, because he's mentioned almost a semicircular one. Then you end up getting theta is 180. This would become 4 alpha by g under root. And when you substitute all those three values numerically given in the question and take a square root, you end up getting approximately 5.29 mm. And most of the students after the exam came and wrote in the comment section of that old video that they were very lucky to have seen the solution and got it right. But to their displeasure and to my shock, JE gave this as the answer. Okay, right. And they kept this answer in the final key, 3.74 mm. They were supported by some other institutes keys also, right? And even though we knew that this particular answer was wrong, and I was confronting some of the teachers from the other institutes also who have come up with this JE matching key. They did not object to the JE key because their toppers, their top students have attempted the question in this wrong manner. Okay, so in case objections were accepted, they would have got it wrong. Okay, so that was very unfair way. And it's not just about majority, it should be accepted on the basis of what is correct. Okay, so let's try to see why the JE answer is wrong. Okay, so first of all, let's try to understand how JE or the other institutes who gave this as the key arrived at this answer, and we'll try to find flaws in that argument by multiple ways. Okay, right. I hope you're ready to dissect this. So what was the JE's proposed solution? Okay, so let's go very slow. If I take this small bulge and take their assumption seriously that this was a semicircular shape, okay, right? And into the board, there is a DL width, and I cut that semicircular part and place it here, okay, right? And if this is semicircular shape in this particular plane, then it's considered to be a hemi-cylindrical drop of certain width in the into the board, if DL is the into the board. Okay, so if this is zero gauge pressure, I'm writing only gauge pressures here, atmospheric pressure anyway cancels out. Okay, so zero gauge pressure, then at a height h below, which is nothing but 2r, once you are assuming this as semicircular, at the bottom the gauge pressure will become rho gh. He says the value of this should equal to the surface tension pressure that it can overcome. Once this is a hemi-cylindrical drop, outside if it is 0, inside it should be alpha divided by r. Actually, using Young's formula of two radii of curvature, one radius of curvature is capital R, another one would be this round thing as you go around this particular cylindrical drop. Okay, so you should have written alpha by r1 plus alpha by r2, where the bigger R is so large that you can neglect that. So that's why you end up getting only alpha by r at this place. Since he's assuming this is semicircular, which means this is all uniform pressure, it has to be, right? Because outside, if it is uniform and the curvature is the same throughout, then the pressure inside should be the same. That is where the flaw lies. Let's go ahead with the flaw. Okay, so the value of rho gh here should be equal to alpha by r, and h is anyway 2r. Therefore, if you substitute for h in terms of r and rearrange, you end up getting that particular root 2 alpha by rho g, which was given as the final key. They gave it as tentative key, some institutes supported it, and they left it as the final key, going against the previous Olympiad question and also common sense. Okay, so now let's learn lots of concepts in proving this wrong. Okay, so, and I'll answer some of the comments that the previous video also had about the vertical balance. Okay, right? I will do it in a very quick manner before we move on to the practice problem. So I would recommend, if you're a new student to this channel, to be watching a video and reading the comments below that video. That video's thumbnail I have produced here, and link of this video is in the description below or on the I button above. It catered to the understanding of microscopic and macroscopic FBDs in any capillary tube, and also it tried to differentiate and explain elaborately to students what are the three different types of surface tension that we deal with in this common formula, TSL, TSG, or TLG, how they make their appearance. Okay, so this is a very important one, and we'll be borrowing some important aspects from this particular video. Okay, so going forward, borrowing the essence of that previous video that I was just highlighting, in that whenever a drop is placed on a solid material, and here you are seeing acute angle of contact, there are interfaces. There are three types of interfaces. One is the liquid air interface. Okay, and then there is a solid liquid interface, and then there is a solid air interface also. Okay, and then there is a three-phase contact point. One thing that you should understand is that whenever someone asks at this interface, what are the types of molecules you're taking, and then you should take, interface is actually a small volume containing molecules of both sides, that is liquid and air here, and here it is liquid and solid, and here it is solid and air, and in a three-phase contact line, whenever someone draws a microscopic FBD by taking collection of molecules at a three-phase contact, then it should contain all three types of molecules. It's not just the DM element of the liquid that you are writing, for which the equations are written here. This is three-phase contact point, and then you write this equation to balance it in the horizontal direction. Okay, right? Argument by some students is that if I balance it in the horizontal direction, then in vertical direction, who balances it? Because there is a sine theta term that comes from TLG. Okay, so to just answer that, we need to go back to my solution diagram. Okay, so from that first video where the bulges FBD was written here, can you see? Okay, right? And in that video, I need to make a small correction. This is, at that also I highlighted, this is theta minus 180. Okay, right? I wrote it as 180 minus theta. Theta is obtuse. Okay, right? So this should be something associated with that. Okay, so acute angle, take the modulus of that. So in this scenario, if I want to balance it in the vertical direction, okay, right? In that comment section, I've shared a file for one student who asked. It was a big research paper. It was an interesting one. Okay, so if you want a more elaborate explanation for the vertical forces, I'll take up another video, but try to understand. This is one of the excerpts or a snapshot from that research paper that I shared in the comment section there. Okay, in that first video that I highlighted. Okay, so whenever you have a drop here, okay, in our textbooks, we are mostly concerned with horizontal forces, but in vertical direction also, there will be forces that are explained by the Laplace pressure. Okay, whether it is attractive or repulsive, that we can take to balance it. Okay, so the system is in equilibrium, so that sum of all external forces must be zero on this drop. Okay, due to Laplace pressure, there is a repulsive force exerted by solid on the liquid across the liquid solid interface. These dotted arrows that you have, even if you take a small three-phase contact point here also, these arrows would push it in the upward direction. So those arrows here in the rightward direction would have a upward repulsive force, is what that research paper explains. Okay, since we don't have enough time in this video, right, I'm going to take that as the aspect and move forward to the torque method. Okay, so that's what, but my promise is, if the channel goes very well, I will definitely take up a separate video to explain all the nitty-gritties of the surface tension, that the textbooks don't, but that are required. So this sine theta force that we were looking at in the vertical direction also gets balanced. Okay, right. So go to that. If you want this particular research paper, go to the comment section of that previous video that I highlighted at the start of this in order to get the elaborate understanding. Okay, or we'll do a video on that. Now, proving why semicircular disc shape assumed by JEE is wrong. So, while proving it, we'll understand many more concepts. Okay, I took the bulge in a semicircular shape as requested by JEE, and now I'm going to prove why this can't be semicircular, right? So it's like a proof by contradiction. So just like previously, take this bulge. Imagine there is a width dl into the board so that it's a volume element. Okay, and from that Laplace repulsion pressure that I talked about, there should be some set of molecules here, all the three phase points that will be there, and these molecules will definitely have an upward repulsive force in order to balance this DMG. Okay, right? So that is settled. Since we don't know the value of that, let's suppose, and you can equate it to DMG, and we don't want to get into that, I would try to use a torque about this contact point P at the bottom of that bulge in order to avoid this calculation. It's there, it will balance, but let's try to avoid it during our set of calculations. So by taking that, I will eliminate this repulsive upward force and the alpha DL force, and the torque due to rest of the forces will be considered. Now, if this is semicircular disk type of situation, the center of mass should be at a distance of 4r by 3 pi. We know that. And h is already 2r, this h is. Okay. So alpha into dl, one force, and the pressure force, which is distributed over an area. Remember, this is one line and there's a dl into the board. It's a rectangular area on which this rho gh will be linearly varying. So the torque of alpha dl, this rho gh distributed force, and dmg should balance to 0. So to make some calculations, what is the value of DMG for this disk with a width DL? It should be density into area of the disk multiplied by the width, which is DL into the board. And for linear variation of this gauge pressure, please don't put the pressure at the midpoint. It will actually come at a distance of h by 3 from the bottom. Okay, or you can write this equation and integrate the torque, you'll end up getting the same result. Okay, so which is varying linearly from 0 to rho gh, the point of application is h by 3 from point P. Using this torque about point P, right? Take all the torques which are rotating it in clockwise sense and add it to the anti-clockwise and make it 0. So alpha dl into 2r, this top one, this 2r, okay, is the only anti-clockwise torque, whereas this DMG torque, which is this number, sorry, DMG torque is this number, and rho gh linear variation torque is this one. You could see what I have written, rho gh by 2, which is the average value of this pressure, multiplied by area, which is 2r into dl, but placed at a position of h by 3 from P. That's why 2r by 3. Okay, and cancel dl's throughout and rearrange to get the value of that x for this to be true. Torque balance has to be true if J is assuming it to be disk, right? So once you rearrange and solve for this x based on his assumption h is equal to 2r, and for that I need this 2 alpha to be written. So I'll substitute the JE's answer. What was the JE's answer? JE's answer was this, h is equal to 2 alpha by rho g was the assumption. So I substitute 2 alpha is rho g h square. Okay, and cancel all the unnecessary terms. I get x is 16r by 3 pi, which is 4 times of what is supposed to be for a semicircular disk, which itself tells you that the assumptions were so contradictory that you'll never have a semicircular disk. Actually, this curvature can't be symmetric. And that's what our Pathfinder question and my previous video actually tries to prove, right? So my simple request to JE and JE aspirants separately, before we move on to the practice problems, is very simple. Please kindly don't provide assumptions which are physically contradicting and impossible. It's like a lot of teachers have argued with me, and also some students who said, okay, since they asked for semicircular, I'll take semicircular. But that is going against and penalizing students who actually knew the situation and who did the correct physics solution. You're penalizing them by actually not even deleting the question. You made a mistake and you're sticking to that mistake when you're giving the final key. Okay, right. It's like next time they will say two bodies are colliding inelastically with each other and consider kinetic energy is conserved. In elastic collision, kinetic energy is not conserved. You can't give two contradicting statements within a same problem and ask the students to take it. Physically, there should be possible statements. Approximations are okay, but contradicting assumptions are not uh, not at all cool. Okay, so it's just a request. I know students don't share my videos to anyone and may not reach to the JE people and all that, but in case you're kind enough to share this video and share the channel's content, it reaches people concerned, then in future these kind of things can be avoided. On the positive side, let's suppose these are not avoided also, the advice for JE aspirants is never, it's not a video to mock JE, right? It's about pointing out the mistakes, and from that mistake we have enough chance to correct our concepts, and not only just correct them, enhance the understanding. So dissecting a wrong JE mains and advanced problem in all the directions of thinking possible, right? Force, torque, energy, pressure, curvatures, etc., enhances your understanding not only in surface tension but also other topics. On that bright note, let me tell you, JE and surface tension have never been good friends. Okay, right? So just a simple depiction to lighten up the video, that this is JE and this is the surface tension and they're fighting over the theory. Okay, let's there are many examples. Okay, length of the video will not allow me to put forward all of them. I'll give you two examples, one from mains and one from advanced, to prove my point. Okay, and I'll take up the solutions of this in the series if at all the channel continues. Okay, so one is from 2010 JE paper. Okay, this is an eyedrop question where an eyedropper machine, and the drop is coming out, and when the drop actually loses contact, and again I have a very serious physics issue with the 50th question of this comprehension. So please do try it. Comment along with the timestamp below in the comments what is debatable about this question and the key given by the JE. Okay, 2010, very old paper, so very old rivalry that they have with surface tension. The second one I picked from JE mains because mains is coming very close and they are going to announce the dates. I'll be reviving this JE mains debated questions series that I have already produced some videos highlighting the concepts important, right, by taking debated questions across the JE mains papers. So this is one of them I picked from, I think, 2014 paper. I don't remember the exact year. Question is important, so try this one out. There's bubbles which are coming out from a bottom of a vessel. Okay, so 4 options were given. Final key is something that was debated at that time. So comment along with the timestamp on what you find about this problem as debatable, and I'll try to produce the video in the JE mains debated questions. Okay, so and also new students, they can check this series of questions, both the JE advanced solutions series and JE mains debated questions series, links of which are in the description below. Okay, right? And surface tension is actually a beautiful topic. In order to understand the flair and beauty of this topic, I would request you to go to the playlist of this channel's surface tension and find the videos in sequence. I already highlighted 2 of the videos in this, so there are 6 to 7 of them I have produced by now, and link of the playlist is also in the I button above or in the description. Please do watch it, and definitely I will understand. I'm very confident that you will start loving surface tension, not like what JE does to it. Okay, right? And in case you are wanting much faster resolutions or discussions of surface tension, because the channel videos are going to get delayed as the condition I have already put, there is a separate surface tension channel in our Discord server where some JE problems have been shared by good students, and they're getting discussed both by me and also the students together, and discussions happen much faster in the Discord server. So please do join it. And in case you are new and you don't know what is Discord server, I've already made a video tutorial. You can find it in the video section. Also, link of that is in the I button above or the description below. Watch it, join the server, and enjoy the discussions. Okay, so let me reiterate, the next video will only come once this particular video reaches 500 likes. I again simply request you, like it if you definitely like it, don't like it if you don't like it. It's as simple. After liking it and appreciating it in your mind and not just pressing the like button out of laziness or selfishness, that is not cool, and it's definitely not motivating for me. Okay, so once it reaches 500 likes, I will definitely come up with the next awesome video that you definitely know what I am capable of. Okay, so in case you share this content and the subscribers reach 8K, whichever happens first, 500 likes or the 8K subscribers, I'll definitely come up with a next important video for your JEE preparation, especially JEE Advanced 2021 aspirants would be interested because the exam is coming nearer. And if any of these conditions don't match also, I'll come up with the video, but at my own pace, my own time that I would like to take. Okay. Thanks for understanding. I hope you can understand my heart and mind in putting up this condition. And please do know about, comment about all the things that I asked in this particular video below, and stay connected and stay happy. Thank you and see you in the next one.